Alright, so we're here doing chapter 5, number 18, and that problem reads, a box with a 75 kilogram passenger inside is launched straight up into the air by a giant rubber band. After the box has left the rubber band but is still moving upward, A, what is the passenger's true weight? B, what is the passenger's apparent weight? Alright, so if we just draw a little picture of a guy in a box, we get something that looks like this. And if we draw his free body diagram to show what he looks like, we've got his weight going down, which is equal to mass times gravity, and we have this normal force pushing up on him from the box. All right, so we know that his mass is 75 kilograms, so we'll put that in. And we can start with part A. Now part A says, what is his real weight? So very simply, weight is equal to mass times gravity. And there then we get 75 times 10. All right, or his weight is going to be to 750 newtons. So that one's pretty quick, pretty simple. Now we'll go with part B. So for part B, the rubber band is not pushing him anymore. He's flying through the air. He's in free fall because only gravity is acting on him. So we can start with Newton's second law in the y direction. We get ma sub y. And looking at his free body diagram, we have the normal force minus his weight is equal to ma sub y. And if we do a little bit of extra work, we get then that m, then a sub y plus g, and we've got our apparent weight equation. So he's in free fall. So his a sub y, in this case, is going to be equal to gravity. So we can call it 10 meters per second. So when we plug that in, we get 75, and then 9.8 minus 9.8, that's the direction he's accelerating in, even though he's traveling upwards. Gravity is still pulling him down. And then we get that other 9.8 in there. So we see that the normal force, which is his apparent weight, is equal to 0. So while he actually weighs 750 newtons, he feels like he weighs 0 because he is accelerating in the direction opposite of his weight. So that kind of explains why when you jump off of a bridge, you ever gone bridge jumping, or you have gone on a roller coaster or one of those amusement park rides that kind of shoots you up, and you feel that kind of tingling in your belly when you're in free fall, that's because there's now no normal force applied to you, and gravity is canceling out your weight, so you feel weightless. You may not be weightless, but you feel weightless because you feel that, that cancellation of acceleration. So that was number 18.